Okay, I thought I'd save us some time and make a video of the key for exam 1. Anyway, this question says it's about alkanes. So you go to your cheat sheet, look up alkanes, and you find out that this is by naming it 1, 2, 3, 4, 5, 6, 7, 8, 10, so it's an alkane. It's going to end in ane, and it's a decane. Okay, now we have to draw this thing, a cycloheptane. So that's going to be a cyclic ring with 7 sides. 1, 2, 3, 4, 5, 6, 7. Okay. This is a question about isomers. Below, which would you expect to have the higher boiling point? So we said in terms of isomers, flatter, stickier, higher. So the thing is, this isomer is over here. And if these two are in the plane, this is out of the plane, and this one is behind the plane. So this is not flat at all. Whereas this guy, 2, 3, 4, 5, is flat. So this is going to be flatter, stickier, higher boiling point. Okay, this is alkenes and alkanes. So you go to your cheat sheet and you look up alkenes or alkanes. You see a triple bond. That's an alkyne, so it's going to end in ine. The longest chain is 1, 2, 3, 4, 5, 6, 7, 8. So that's octine, and we could count in this direction or this direction, but we get to the triple bond first in this direction. So that's 1, 2, 3, 4, 5, 6, 7, 8. So this is 1, 2, 3, 3 octine. Okay, cycloheptene. So this is the same basically as cycloheptane, only it's an ene, so it's going to have a double bond. So we draw the 7-membered ring, and we put in a double bond, cycloheptene. Okay, this is a hydration reaction. So we're going to add water across this double bond. So the OH goes there, the H goes there, and we get rid of the double bond. So that's simply going to be so this is cyclohexanol. All right, substituent groups. And again, you kind of work backwards. So this is an alkane. It's only got single bonds. Longest chain is 1, 2, 3, 4, 5, 6. So this is a hexane. So what comes first is this. So this is 1, 2, 2 bromo. This comes next. This is a 1, 2, 3, 3 chloro. And this is a 1, 2, 3, 4, 4 methyl. B comes first, so that's going to be 2 bromo, 3 chloro, 4 methyl hexane. Okay, so we got to draw this guy. It's going to be a cyclohexane. It's going to have a bromo on carbon 1. It's going to have 1, 2, 3, a chloro on carbon 3, and it's going to have a methyl on carbon 5. Bromo, chloro. So this is 1 bromo, 3 chloro, 5 methyl cyclohexane. Okay, this is a hydrogenation reaction, so we're going to add hydrogen across this double bond. So this hydrogen goes there, this hydrogen goes there, and this double bond goes away. So that's going to be quite simply this. Okay, now this is a cis trans question. So what is the parent name? It's an alkene, so it's going to end in an ene. Longest chain is 1, 2, 3, 4, 5, 6, 7. So that's hept. The double bond comes at carbon 2. And the chloro comes at 1, 2, 3, 4, 5, carbon 5. So that's 5 chloro. And it's in a trans configuration. So that's trans. Trans 5 chloro 2 heptene. Okay, so we have to draw this. Working backwards, this is an ethene. So this is line angle. So it's a difluoro, and it's on carbons 1 and 2, and they're cis, so they're on the same side. There you go. That's it. Okay, so this question. Draw the product formed following the hydrogenation of 7A using H2 gas and palladium as the catalyst. So 7,2A is this guy. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And the double bond is there, and the chloro is there. And we're going to add hydrogen across this double bond. So this hydrogen goes here, this hydrogen goes here, and this double bond goes away. So that's 2, 3, 4, 5, 6, 7. 2, 3, 2. 1, 2, 3, 4, 5, 6, 7. And on carbon 5 is the chloro. 1, 2, 3, 4, 5. Okay. Now, this is an aromatic. So you go to your cheat sheet, you look up page 4, and you try to identify the aromatic structure that closely fits this compound. And you see that this is toluene. So this part is toluene. And it's got 1, 2, 3 iodos. So it's got an iodo at position 2. And one at position 1, 2, 3, 4. And one at position 1, 2, 3, 4, 5, 6. There are 3 of them, so it's tri iodo toluene. Okay, so again, aromatic, you look at the aromatic cheat sheet and you see aniline. And aniline is this guy. Basically, it's aminobenzene. And the substituent group is 4-bromo. So that's 1, 2, 3, 4 bromo. 4-bromo aniline. Okay, this question, what is the monomer that forms this polymer? And if you remember, we just put brackets around the core 2 pieces. And this bond goes there. And this bond goes away. So we end up with CH2 double bond CH benzene ring. There you go. Okay, a lot of people had trouble with this one, but you just basically stick with the rules. So this is an alcohol. You go to the alcohol cheat sheet. So it's going to end in an all. What's the longest chain? 1, 2, 3, 1, 2, 3, 3. So that's prop. And the alcohol's on carbon 2. So we've accounted for all of this, which is 2-propanol. And we just have to account for that, which is 2-methyl. 2-methyl, 2-propanol. So this one, it's going to be a cyclohexanol, so that's a 6-membered ring, OH. And a bromo is on carbon 3. This is carbon 1, 2, 3, bromo. 1 octanol is soluble in water. Well, we know that carbons that are greater or equal to 5 as an alcohol are insoluble. So an alcohol which has 5 or more carbons is going to be insoluble. Octanol has 8 carbons, so this is not soluble, so it's false. Okay, aldehydes. You go to your cheat sheet, you find aldehydes. And so an aldehyde is going to end in an al. Longest chain, you got to start there. The aldehyde defines the first carbon, 1, 2, 3, 4, 5, 6. So it's a hex. Hexanal, you don't have to state 1 because it's always going to be 1. You have to put in the substituent groups. This is a 1, 2, 3, 4, 4 bromo. And this is a 1, 2, 3, 3 methyl. And so this guy, you start with the lower, you start alphabetically with B over M, so this becomes 4 bromo 3 methyl hexanol. So let's go to this one, and you say to yourself, oh my gosh, this is the same name as what I've just written, 4-bromo-3-methyl-hexanol. So I just have to copy this guy up here, and I got the right answer. There you go. But if you didn't realize that, you would do it this way. It's going to be an aldehyde. And it's going to have 6 carbons. So you draw your 6 carbons. 1, 2, 3, 4, 5, 6. This is going to be the aldehyde end. And it's going to have a 4-bromo. 1, 2, 3, 4. And it's going to have a 3-methyl. 1, 2, 3. And everything else you fill in with hydrogens. 4 bonds to carbon. There you go. These two guys are the same. Okay, what if I oxidize 13A? Here's 13A. It's an aldehyde. You know from your flashcards, the oxidation of an aldehyde is a carboxylic acid, which is A. Okay, now we're going to ketones. Cheat sheet, you find your ketone on the cheat sheet. It's going to end in an -one. Longest chain is 1, 2, 3, 4, 5, 6. So it's a hexanone. We can count this way or this way, but if we count this way, we get to the carbonyl faster, which is on carbon 1, 2. So this is a 2-hexanone. We have to name this substituent group. Don't be confused. It's not a propane. This is an ethane or ethyl group. And it's on carbon, again, 1, 2, 3, 4. 4. So this is 4-ethyl 2-hexanone. All right. 15A. Let's look at 15A, which is this guy. And we're going to oxidize it. If you look at your flashcards, you know that ketones cannot be oxidized. So this is no reaction. So now you go to your cheat sheet under ethers. And you see this guy, and the longest chain is named as an alkane, is a cyclohexane. So this part is a cyclohexane. Now we have to name this part, which is methoxy. Cyclohexane. Because it's a ring, we don't have to designate this as a 1, so it's just methoxycyclohexane. Look at this way, methoxymethane. So again, this is an alkane. It's meth, so it's got 1 carbon. And then we have to just do that part. Methoxy, that's the same thing that's up here. And we fill in the hydrogens. Methoxymethane. Okay, explain why the alcohol isomer in 17B is more water soluble. Well, the alcohol isomer is going to be this, which is ethanol. This is ethanol, the alcohol. This is methoxymethane, the ether. And you remember from trends that alcohols are more soluble than ethers. So, and that's because you have three possibilities of hydrogen bonding. That's one. The hydrogen is 2. This double bond is 3. 3 chances of hydrogen bonding, but only 2 chances for the methoxymethane. 1, 2. So the alcohol has more hydrogen bonds. More hydrogen bonds. Okay. So you go to your cheat sheet, thiols. This is going to be end in N, thiol. And this group, longest chain is cyclohexanethiol. Cyclohexanethiol. And you look down here and lo and behold, you see that's the same name we have here, cyclohexanethiol. Cyclohexanethiol, that's the same thing we drew. So obviously it's going to be the same structure. And then for the next question, there's no circle in the middle or 3 sets of double bonds, so it's not aromatic. The structure in 19A is an aromatic compound, and there is no circle in the middle of that 6-membered ring, and there are no double bonds in it, so that's going to be false. It is not aromatic. Okay, which structure below is a hemiacetal? So you look at your flashcards and you see that a hemiacetal has a hydroxyl group, an alcohol group, and an ether group. Whereas the acetal has 2 ether groups, but it wants to know the hemiacetal, which should have a hydroxyl group or alcohol group and an ether group. So this guy is the hemiacetal. Now, if you remember, this part of the molecule is where the ketone comes from. So it's CH3, CH2, actually C double bond O. Oops. Yeah, so it's CH3, CH2, C double bond O, and CH3. So do you see that this part of the molecule is this ketone, which is butanone? And then this part of the molecule is where the alcohol comes from. The alcohol comes from this part. In this case, the ketone comes from this part. So the alcohol that was used to form this hemiacetal is this guy right here. CH3, which is methanol. Okay. Okay, identify each of the structures below as chiral or achiral. So you have to have 4 different groups. This only has 2 groups. This carbon, these are the same substituents, so it only has 3 groups. This only has 2 groups that are different. But this guy has 4 different groups. There's 1, there's 2, there's 3, and there's 4. So there are 4 different groups attached to this. So this is chiral. Okay, let's check this one out. There are only 2 groups attached to this carbon. There are only 3 groups attached to this carbon. That's 1, 2, 3. Only 3 groups. There are only 3 groups attached to this carbon. That's 1, 2, 3. And there are only 2 groups attached to this carbon. 2 different groups. So this is achiral. We do not see 4 different groups attached to any one of these carbons. Okay, this carbon, these 2 groups are the same, so there are only 3 different groups attached to this carbon, so that doesn't count. And this guy right here, there's a different group, there's a different group, that. So this has 4 different groups. That's 1, 2, 3, 4. So it's chiral. This guy, there are 3 different groups attached to this carbon. It needs 4. There are only 2 different groups attached to this carbon. So that's achiral. But this carbon right here has 4 different groups. This is 1 group that's different, 2 groups that's different, 3 that are different, and this hydrogen is the 4th that's different. So this is chiral. 4 different groups. Okay, I think most people got this one right. So you go to the base chiral carbon, which is this. The OH is on the left, so this is L. You go to the base bottom chiral carbon, which is this. The OH is on the left, so this is L. You go to the base chiral carbon, which is this. The OH is on the right, so this is D. You go to the base chiral carbon, which is this one. The OH is on the right, so this is D. Okay, based on the principles of evolution, such as survival of the fittest and survival to those that adapt, why do biological organisms use D rather than L-glucose? So the D and the L isomers, they are virtually the same. They are mirror images of each other. There is nothing different about these 2 molecules, D-L, in terms of physical, chemical properties. They are identical. The only thing that's different is that they are mirror images of each other. So because they are identical, that is like your 2 hands are identical, but they're mirror images, D is going to be the same as that L. It's not going to be stronger. L stands for loser. Well, that's stupid. Luck of the draw. That actually could be an answer. That could be an answer. It just so happened that D got lucky. So that could be an answer. But I like to think that there is no explanation based on the principles of evolution, which is also could be an answer. Anyway, I did not grade off on this question. So this question was a gift. Extra credit. So which of these 3 guys is John Althouse? You know, the only thing I can say is, which one of these 3 guys would your mom tell you to stay away from? Stay away from this guy. It would obviously be the drugger hippie, which is this guy right here. So it's the one on the left. Let me go over how I graded. So each question was worth 4 points. So this got a point, A got a point, B got a point. A got 2 points. B got 2 points. So question number 1 got a total of 4 points. A was worth 2. B was worth 2. So that's 4 points. If you made a simple single mistake, you got 1 off. But if you made more than 1 mistake, you got 2 off for these kinds of questions. Now, these questions are worth 4 points. So you either got it right or you got it wrong. And if you got it wrong, you lost 4 points. So really double check these kinds of questions that are worth 4 points. And again, A is worth 2 points, B is worth 2 points. If you made a simple mistake, you got 1 off, but if you made more than 1 mistake on any given question, you would get 2 off. Anyway, let me know if you have any questions. Okay, I skipped over this one right here. Number 15B. And you're probably thinking, oh my gosh, he skipped over that. I better get on the horn and let him know. But luckily I figured that out and I'm going to go over it. Anyway, again, this is ketone. We're going to draw. So it ends in cyclohexanone, cyclohexanone. So that's going to be this. Cyclohexanone. But it's 4,4-dichloro. That's a little bit confusing, but you must realize that not shown are 2 hydrogens, right? These all have 2 hydrogens that are not shown because it's line angle. So these are substituents. So the 2 hydrogens that are at this carbon are being substituted for chloro. There's 1 chloro and there's 2 chloro. So, and they're all on the 4th carbon. 1, 2, 3, 4. 4,4-dichlorocyclohexanone.